Okay. So we have done so far on the rotates and the shape. So we are going to the last one, which is the bit manipulation instructions, which is on another 4. Bit change, bit clear, bit set, and bit test. Only 4 of them. Okay. All of this will look at Z flag, which is your CCR code. This is very important. Okay. Let's look at it one by one. The command syntax will be in this terms of format. We change, we clear, we set, we test. So this is the one. Data register to effective address, number to effective address, and the rest is like this only. So you just need to know that it can be byte and long word, and the condition codes is only Z flag. You have to look at the Z flag today. Okay, look at the Z flags today for the simulation. Okay, let's go for the first one. The definition. So look at the definition, it's very simple, because if you understand this, it's very simple. It requires to test and do something. Test and do something. Okay, the first one is bit change. Bit change means you have to test the bit and then change accordingly, which is to invert the value. If the value is 0, then you have to change to 1. If the value is 1, you have to change to 0. So that's the meaning of change. Change, very simple. Change, first you test the bit and then you invert the value. Okay? Test, look at Z flag, and then later you invert. Okay? The next one, bit clear. Clear means 0. Same thing again. If you clear, you have to test the bit. Look at the Z flag change and then make it 0. Clear. Okay. The third one is bit set. Set is equivalent to 1. Set. You test the bit first. Look at the Z again and then go to 1, change to 1. And the last one, bit test. If bit test is only test. Test and just look at the Z flag. That's all, no changes. That is the definition. So look at the simulator, let's try one by one. So the first one is what you want to see, bit test. Okay, bit test. Go and write this one. Bit test, bit test, bit test. Okay, right now, look at that one first. Quick one, 2-3 minutes, it should be completed in your simulator. Look at the result. You should understand what I'm doing over there, Origin FM, and it refers to your slide. This is an example of your slide. You have to open up the slides to look at the example, what the example says. Alright, do that one first. Done, everybody? Okay, let's look at the slides again. The slides say The slide say the command will be like this. Just now is what bit change, eh? Bit test, eh? The one, the first one?
Yes.
Bit test. Bit test, you have these types of format. The first one is the bit test data register effective address. You are taking the second one, bit test a number, then the effective address. This is your memory side. This is actually the number, bit number. That's what call it bit number. So what is the number bit, right? So let's look at this one. Okay, compile this one, execute, and then look at this one by one. So origin FF8000 define constant dot by AA. So you know that from the slides, I'm putting something in the memory. My memory locations have FF8000 LOB, FF8000 view memory. FF8000. Oh, sorry. F802. So that value is already over here. It's correct, right? My code said that. So now my program say what? My program say origin 1000 bit test dot by #2. #2 the location. Right? That is the location. Then you have to look at the data to that. So right now what you only see is that is AA. AA16, right? So now change to bit in binary, which is 10 10 10 10. Okay, right? So the question is bit test dot by AA, which is AA, this one, #2. 2 means bit number 2. Bit number 2 is over here. This is bit 0. This is bit 1. This is bit number 2. Alright, you have this one 0, 1, 2, 3, 4, 5, 6, 7. You have 7 bits, the sequence. So you are testing bit number 2. So now the bit test will test this value. If the value is 0, then your Z flag will be equivalent to 1. If your test bit is equivalent to 1, your Z flag will remain 0. So let's try that one. Correct or not? Look at the Z flag on the CCR code. Here we test that one. So let's test it. Bit test does not change anything. It just only tests. Look at the Z flag only. So now run that one. Your change will be on the Z flag here. Correct? So let's try you test bit number 0, 1, 2, 3, 4. You test number 4. The Z flag will remain what? You change this one bit test by #4. Now you are testing this bit. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Still 1? Alright. Let's test 5. Bit test 5. #5. You test it, you can test. 0, right? So you know that if you test based on the number, it will based on this number, binary. If you find 1, the Z flag will change to 1, 0. If 0, Z is equivalent to 1. Alright, there's no change on the value, only Z flag. Okay, easy, eh? Okay, let's run. If you have any questions, let's move on. Okay, the next one is bit clear. Right, this is the bit clear, so we'll try to run this one. Bit clear. Okay, run this one again. Alright, that's the command. So look at your slides again, correct or not what I'm doing based on the slides example. So that one is to clear a bit. Now it's using another format, which is data register and data register. Okay, now look at the results. Look at the results, that's what you have to understand. Big clear dot long now is data register, the other format just now, data register and data register. But no matter what, the first one will represent the bit number. So for this example, D5 is equivalent to C. C is equivalent to 12, correct? A is 10, B is 11, C is 12. So it means that you have to look at the bit number 12. So based on that D3, you have to go for the whole word, find out the bit number 12. So what you have to do is, so D3 is equivalent to the whole number. If I want to take long, it's very long, I have to do it lah. So now 7. 7, 4, 7 is 0, 1, 1, 1. 4 is 0, 1, 0, 0. 7 is 0, 1, 1, 1. 6 is 0, 1, 1, 0. 2 is 0, 0, 1, 0. 6 is 0, 1, 1, 0. And 0, 0, 0, 0, 0. 0, 0, 0, 0. Right. So far, I changed the whole thing. Now the question asks you to clear dot long D5. D5 means the number 12, which is over here. C is equivalent to 12. Right. The first one is the bit number. This is the D3. You need to test it or you need to clear it in this question. So now the bit number is number C, which is equivalent to 12. So you have to calculate from here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Is it the same one in the slides? Oh, 13, not 12, sorry. A is 10. A is equal to 10, B is equivalent to 11, C is equivalent to 12. Oh, in the slides, no, in the slides is D. Sorry, in the slide is D. I changed it for the testing as well. So change again this one. This one to D. I play around with the number because I want to see the results. So in the slide, the question is D5 is equivalent to D. So this is YD. D is equivalent to 13. 13 is this one. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This is the bit number 13. Right? The question tell you guys that you need to clear bit number 13. So the only clear means is this bit, which is from 1 to 0. You clear it. The final answer is this one. You clear this bit. So the rest is still the same. So the final answer for D3 or D5? D3 is equivalent to 7, 4, 7, 6, 0. Because this is changed already. This part already changed. 6, 0, 0. So look at the answer. In the answer just now, D5 is here. So look at D5 and D3. Run one by one. D5, D3. Now you are going to clear something at D3. The original value is 74762 600, and you clear only one bit at bit number 13, and the last result is this. See, this one is sorry, this one is. So the final result will be 74776 0600. This number had been changed from 2 to 0 because you clear this bit. Okay? Clear that bit. This one should be okay. Right? Let's move on. So you have bit test, you have bit clear. Now let's move on to the next one, next example. Next is bit change. Bit change. So look at the example for bit change. The command line will be like this. Bit change. Okay, that's the number, that's the syntax. Do it on your PC. Write down the PC and look at the result. Compare the result. Number 6. Change means you have to invert. No matter what's the value, you need to invert. Okay, look at the answer. You still need to look at the Z flag. You have to look at the Z flag. No matter what, the Z flag is very important. In this test, change, clear, and set. Okay, now D5 you need to test bit number 6. So let's start again. 4 is equivalent to 0, 1, 0, 0. 8 is 1, 0. 1 is equivalent to 0, 0, 0, 1. C is 12. 12 means 1, 1, 0, 1. 1, 1, 0, right? 12. 2 is equivalent to 0, 0, 1, 0. 8 is equivalent to 1, 0, 1, 0. And 8 is equivalent to 1, 0, 0, 2. Okay, bit number 6. Bit number 6, you have to calculate from here, count from here. 0, 1, 2, 3, 4, 5, 6. This is bit number 6. So the command asks you to change the value, but you have to test first. So the test will be done, and the result is 0, and your Z flag should be changed to 1. And the final answer, you have to change it. You have the value 0, then you have to change to 1. Change it. So the final answer only affects at this number. So the rest is still the same. 4, 8, 2, 1, C, 2. Here is now changed to 1. This is what? E. E. D. E. 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 A. Is it the same answer in the simulator? So let's run it. So Z flag will be equivalent to 1 because it tests 0. So now we change. We have the result Z is equivalent to 1. We have the final result for D5 is E8. Okay? So this command for bit manipulation, you must check Z flag. So let's move on. The next one, the last one. Last one is bit set. Okay, now there's another. This is using another format. Z set. Okay, run the one. This is quite different because it's using bracket and using address register. Address register bracket. You should understand now all the codes. Every line and line. It shouldn't be a problem anymore. You have to do this. So right now the format is the bit different, but you have seen this format before in chapter 3, is a bracket address register. So it means that you are referring to the memory location given from the address register. Correct? It's not a direct one. So now, origin 2000, you can see that I already put this value at origin 2000, then this is your command. So move.long this number to A0, this is 2001. 2001 is which one? This is 2000, correct? And this is 2001. From the memory, So now bitset.byte, bitset.byte number 7. You have to refer to this A0. A0 is given as, I don't give anything I give this one, sorry. A0 is this number. Now A0 is this number, which is address register. You are referring to the memory location, which is this value. So 75. Is equivalent to 0, 1, 1, 1. 5 is equivalent to 0, 1, 0, 1. This is 4, right? 4, 0, 1. Alright, bit number 7. Of course, the last one is bit number 7, right? This is bit number 7. So you test first. Test. That value is 0. Your Z flag should be 1. And then what is what? Bit set. Bit set means you have to change to 1. So from 0, you have to change to this one. And the final answer is A. This is F. F5. What happens if you test bit number 6? What happens if you test bit number, not test, sorry, bit set number 6? Change to number 6, you change this one to number 6. Anything changes? Because of what? Because the bit number 6 is already 1. So why you need to set another one, right? Set is meaning 1, unless you change it. Change, you have to revert to 0. If set is equivalent to 1, why you need to set anymore? It's already 1. Same like for clear. If you clear this bit, test this bit 0, you cannot clear it because it's already 0. It's the same thing. So the final answer must be F5. Okay? For that one. So the result, let's double check the result. Okay, now I want to review the memory at 2000. What's the value? 0, 0, 2000. So F5 first. This is the last result. This is the last result. From the value first is 75, and the final answer now is F5. Okay? Any questions? Any more questions? No questions? If there are no questions, if there are no questions, that one should be the end of chapter 5.